In the failing light of December 18, 1944, an American lieutenant named Alvin Edelstein stood on a wooden trestle bridge across the Lynn Creek in the Belgian Ardennes. The water ran cold and dark through the pines. Coming down the road toward him was the most feared armored column in Europe. The mixed spearhead of Kampfgruppe Peiper, Panthers, Panzer IVs, Tiger IIs, and armored half-tracks of the 1st SS Panzer Division Leibstandarte Adolf Hitler. The pride of Heinrich Himmler's army. Lieutenant Edelstein commanded the 2nd platoon of a company, 291st Engineer Combat Battalion. He had no tanks, no anti-tank guns. What he had, packed against the timbers under his boots, was several hundred pounds of TNT and tetritol. The lead Panther reached roughly 200 yards from the bridge. Edelstein turned the plunger. The trestle vanished in a roar of splintered wood and white smoke. On the far bank, SS Lieutenant Colonel Joachim Peiper watched his road disappear into the creek. He slammed his fist on the cupola of his tank. The damned engineers. He had felt the same fury before, at Stavelot, at Trois Ponts, at every river and culvert where a young American officer had reached the demolitions before he did. By December 1944, every senior German officer in the West knew the feeling. Wherever the American advance had to be slowed, wherever a river crossing had to be denied, wherever a minefield had to be planted in a hurry, the Germans found that their enemy had already arrived first and was already digging. This is the story of why that happened. It is the story of an engineering war that history rarely tells, fought not with rifles or fighters, but with mines, detectors, bulldozers, and bridges. A war the Germans began as the world's masters and lost, piece by piece, to a young American corps that had not existed in its wartime form 4 years earlier. The German combat engineer of 1940 was the most respected military engineer in Europe. They were called Pionier. They had taken the Belgian fortress at Eben-Emael in roughly 30 hours of fighting that began with glider troops landing on the roof and shaped charges punching through the armored cupolas. They had bridged the Meuse under fire at Sedan in the same campaign, building the pontoon spans that carried Guderian's panzers across the river and into the open country of northern France. Their training schools at Dessau, Rosslau, and Karlshorst in Berlin produced officers who studied bridge construction, demolition theory, and obstacle planning with the same seriousness that infantry officers studied the rifle. The German military engineering tradition went back to Frederick the Great. By 1940, it had matured into a doctrine that the rest of the world copied. At the heart of that doctrine sat one weapon above all others. The Tellermine, the plate mine, was a flat steel disc roughly 12.5 inches across, packed with 11 pounds of TNT designed to blow the track off any tank that rolled over it. The first model, the Tellermine 35, was issued in 1935. It required between 200 and 400 pounds of pressure to detonate, light enough that a tank would set it off, heavy enough that an infantryman would not. The design was so successful that the Germans built variants through the entire war. The Tellermine 42, the Tellermine 43, each simpler and faster to manufacture than the last. By the end of the war, German factories had produced over 3.5 million Tellermine 43s alone. The Tellermine had a feature that made American engineers fear it for the rest of the war. The pressure plate could be screwed down onto an arming pin. Once that pin sheared, any attempt to unscrew the plate would detonate the mine. American training manuals taught one absolute rule about Tellermines. Never, under any circumstances, remove the pressure plate in the field. You blew the mine in place, or you left it alone. Many American engineers learned that rule the hard way. If the Tellermine was the German answer to the tank, the S-mine was the German answer to the soldier. Officially called the shrapnel mine, unofficially nicknamed the Bouncing Betty by American troops, it was the most feared anti-personnel weapon of the war. about 15 centimeters tall, packed with 360 steel ball bearings or short steel rods around a TNT core. When the tripwire snapped or the pressure prongs went down, a small black powder charge launched the mine 3 to 5 feet into the air. Then the main charge fired, scattering shrapnel horizontally in a lethal radius of about 20 meters and a wounding radius beyond 100. The Germans manufactured nearly 2 million of them between 1935 and 1945. American troops developed an entire mythology around it. One myth, dangerous and untrue, said that if you stayed standing on the trigger, the mine would not fire. The truth was that once the mechanism started, nothing on earth would stop it. The only correct response was to fall flat instantly and pray. There were others. The Riegelmann 43 was a long bar mine, 80 centimeters in length, designed to almost guarantee that a tank track would catch its pressure plate somewhere along its run. The Germans built 3 million of them. The Glassman 43 was a glass bowl filled with 200 grams of explosive, almost invisible to metal detectors, with approximately 11 million units manufactured in the last 2 years of the war. The top mine was made of compressed cardboard and tar with a glass plug fuse, and German engineers identified their own minefields by sprinkling a sandy material called tear sand on them. After the war, the Allies discovered that tear sand was mildly radioactive. The German engineers were finding their own mines with a Geiger counter-style detector called the Stuttgart 43. It was a brilliant solution to a problem the Americans never even tried to solve. By the spring of 1942, this German engineering machine was at its peak. It would never be that strong again. The decline began that summer in the dust and heat of North Africa. When Field Marshal Rommel arrived to take command of Army Group B in early 1944, he walked the cliffs above the French beaches and was horrified. The propaganda spoke of an unbreakable fortress from Norway to Spain. The reality was a thin crust of concrete bunkers, half completed, manned by second-rate divisions, and protected by mine belts that existed mostly on paper. Rommel ordered the construction of a 6-mile deep zone of mines, obstacles, and traps along the entire Channel coast. He calculated that the project required between 50 and 100 million mines. Germany delivered, in the entire span of 1944 leading to D-Day, between 5 and 6 million mines for all of northern France. For the 50-kilometer front of the 352nd Infantry Division at Normandy, Rommel asked for 10 million mines. He received 10,000. He called the entire effort lunacy. The Atlantic Wall, he wrote in a private letter, was a figment of Hitler's cloud cuckoo land. By the time the Americans landed on June 6, 1944, the German Engineering Corps was already fighting a war it could not win on the terms it had set for itself. What the Americans who waded onto the beaches of Normandy faced on that morning was the most concentrated obstacle field any army had attempted to cross in the 20th century. The 6 beaches were backed by approximately 5 million mines laid in the preceding months, a fraction of what Rommel had asked for, but more than any previous amphibious assault had faced. Beyond the beaches lay minefield belts extending inland, laid according to German doctrine in patterns designed to channel attacking forces into pre-registered kill zones. The assault engineers, teams from the 146th and 299th Engineer Combat Battalions on Omaha Beach, teams from the 237th on Utah, had trained specifically for this moment. Each team of roughly 16 men, known as a gap team, was responsible for clearing a 50-yard lane through the obstacles and mines up to the seawall, marking it with flags, and holding the lane open for following waves. On Omaha, those gap teams took catastrophic casualties within the first minutes. German fire raked the beach as engineers tried to place charges on obstacles while the tide came in around them. Of the roughly 272 men who landed as gap team members at Omaha, American military records document that about 40% became casualties in the first 2 hours. They cleared 6 complete lanes instead of the planned 16. It was enough. Through those 6 lanes, the entire American assault at Omaha passed. The mine detector the Americans carried onto those beaches was the SCRAR 625. Built around a simple electromagnetic coil principle, it could locate metal-cased mines with reasonable reliability in soil with low mineral content. In high mineral soil or against the Glassman 43 with its near absence of metal parts, it was nearly useless. German engineers had specifically developed non-metallic mines to defeat exactly this technology. American engineers responded with a method that had not changed significantly since the Napoleonic era. They probed. A soldier lay on the ground or crouched low and systematically inserted a bayonet or a thin steel rod into the earth at a shallow angle, feeling for the resistance of a buried object. Every 12 inches. Forward 8 inches. Probe again. The probe rate was roughly 1 meter per minute in careful conditions, slower under fire, faster with experience but never fast enough that the man probing could be certain he had not missed something. Against German anti-personnel mines fitted with anti-lifting devices, additional fuses that detonated if the mine was raised from the soil, even successful detection offered no guarantee of safety. The engineer who found a tellermine with his bayonet still had to decide whether to blow it in place with a small charge or flag it and move on, leaving it for a following team to destroy. He had to make that decision under fire, with the tide or the advance pushing him forward faster than his training said was safe. The Bangalore torpedo addressed a different obstacle. Developed by British engineers in 1912 for clearing barbed wire obstacles, it was a steel tube 10 feet long and roughly 2.5 inches in diameter, packed with explosive and fitted with a threaded coupling at each end so that multiple sections could be assembled into longer lengths. American engineers crawled forward into wire entanglements, assembled the torpedo section by section under fire, pushed the assembled charge under the wire, and detonated it, blowing a gap through which infantry could pass. At Omaha, Bangalore's opened paths through the wire that covered the exits from the beach. The hedgerow warfare that followed the Normandy landings forced the development of a new engineering solution. The bocage, the ancient system of earthen banks topped with dense vegetation that divided the Norman countryside, was impassable to tanks without modification. Sergeant Curtis Cullen of the 102nd Cavalry Reconnaissance Squadron devised the hedgerow cutter, steel prongs welded to the front of Sherman tanks from German beach obstacles that allowed tanks to burst through the banks at speed rather than climbing over and exposing their belly armor. Around 500 sets were manufactured and fitted before Operation Cobra. General Bradley called it the best new idea of the war. Combined arms engineer infantry armor tactics matured in the bocage over June and early July. A typical hedgerow assault evolved into a precise sequence. Artillery or mortar fire suppressed the German position on the far side of the bank. Smoke masked the approach. Engineers moved forward with Bangalores or demolition charges to blow a gap through the bank or reduce the obstacle. The gap allowed a tank equipped with the Cullen device to push through. Infantry followed, supported by tank fire. The sequence was slow, dangerous, and methodically lethal. The same combined arms integration that Quesada brought to close air support, McNair brought to engineer employment. Engineers were no longer a separate force to be committed when needed. They were woven into every battalion attack, every regimental operation, every divisional advance. In the Hurtgen Forest between September 1944 and February 1945, American engineers faced the hardest conditions of the entire European campaign. The dense pine forest, cut by ravines and streams on terrain that channeled any advance into a handful of narrow approaches, had been mined with a density that American commanders later described as almost incomprehensible. The Germans had saturated every trail, every firebreak, every stream crossing with tellermines and anti-personnel mines laid in patterns specifically designed to defeat the SCAR 625. American engineers clearing trails in the Hurtgen suffered casualty rates that exceeded those of the infantry they supported. One battalion reported losing 30% of its strength in a single week of mine-clearing operations. The work continued regardless. The infantry could not advance without cleared lanes. The tanks could not move without cleared lanes. The engineers cleared the lanes. The Battle of the Bulge brought a different engineering challenge. When Peiper's column struck westward on December 16th, its operational plan depended on capturing American bridges and fuel dumps intact. The American response was the systematic destruction of every bridge, every culvert, every crossing point ahead of the German advance. Engineers raced the Panthers to river crossings across Belgium and Luxembourg, detonating bridges moments ahead of the leading German tanks. Lieutenant Edelstein at Habimont was not an isolated case. He was one example of a pattern that repeated itself dozens of times across the Bulge. The 51st Engineer Combat Battalion destroyed 17 bridges in the first 4 days of the offensive. The 158th Engineer Combat Battalion destroyed 11. American engineers operating ahead of the main defensive line, often with no infantry support and no anti-tank weapons, drove to bridge sites and blew them as German armor appeared on the horizon. The practice saved the Bulge. Peiper's column, which had an operational range of perhaps 150 miles on its available fuel, was forced to abandon its route and attempt alternative crossings repeatedly, losing hours at each denied bridge. It ran out of fuel near La Glaise, 12 miles short of the Meuse, and the crews abandoned their vehicles and walked back to German lines. The mine warfare that unfolded in the retreat toward Germany in early 1945 revealed the full cost of German engineering decisions made under pressure. German pioneers, retreating faster than their doctrine allowed for, laid improvised minefields without complete records. The Minefields, the carefully maintained map of every minefield, updated daily and passed to relieving units, was a central requirement of German engineering doctrine. In the collapse of late 1944 and early 1945, it became impossible to maintain. German mines laid without records killed German soldiers who moved through the same ground days later. They killed civilians. They killed livestock. Glass mines cracked in transit. Cardboard mines rotted in damp soil. Hasty, unmarked retreat fields were a tactical asset against the advancing Americans, but they were a strategic catastrophe because they forfeited the disciplined German tradition of the Minefields. The German engineer had once been a master of measured, patient defensive construction. By 1945, he was a man scattering inferior weapons in the path of an advance he could not stop. When the war ended, the bill for German mine warfare came due. In Denmark, between May and September 1945, German prisoners working under Danish supervision cleared 1,389,281 mines from the Danish coast. 149 of them were killed and 332 wounded in the process, about 20% of the workforce. The Danish-German film Land of Mine, released in 2015, dramatized the operation. In the Netherlands, the Doctor Brigade, about 3,300 Wehrmacht engineers, cleared more than 1 million mines by the end of 1945 and well over 1 million more by the operation's close in 1947. In Norway, around 5,000 German prisoners were sent into the minefields under British command. Several hundred were killed and many more wounded. In France, an estimated 49,000 German prisoners worked in mine clearance from 1945 to 1947. Roughly 1,800 of them died. Mines from the war are still being found today. In the Eifel National Park in western Germany, on the grounds of the former Vogelsang training area, ordnance disposal teams continue to clear Glasman 43s laid more than 80 years ago. The American legacy was different in character, but no less enduring. The engineer school, headquartered at Fort Belvoir during the war, transferred to Fort Leonard Wood, Missouri in 1988. The United States Army Engineer Museum is there today, with a Tellerman, a Schumann, and Skrar 625, and a Bangalore torpedo on permanent display. Every M5 8-line charge, every mine-clearing line charge, every anti-personnel obstacle breaching system in use by the United States military today is the lineal descendant of the Bangalore, plus bayonet, plus bulldozer combined arms approach perfected in the Bocage and the Hurtgen and at the Rhine. There is a particular kind of honor in remembering an engineer. They do not get the parades that the infantry get. They do not get the films that the bomber crews get. The work they did was often invisible, often anonymous, often performed at night and under fire by men whose names appear in no popular history. But they were the men who made every infantry assault possible, every armor breakthrough achievable, every river crossing real. When Sergeant Drabeck ran across the Ludendorff Bridge, when Lieutenant Edelstein dropped the trestle at Habimont, when the gap teams of the 146th and 299th waded into the surf at Omaha, they were doing the work that allowed everyone else's war to happen. Without them, none of the rest of it would have moved. The German engineer of 1940 was the best in the world. The American engineer of 1945 was the best the world had ever seen. The change came not because German engineers stopped being skilled, but because the conditions of the war shifted underneath them. The pioneers were asked to defend a continent with shrinking resources, dying instructors, and improvised materials. The American Corps of Engineers was asked to advance across that continent with the full weight of American industry behind it. Defense rewards patience, thoroughness, and time. The Germans had less of all three with every passing month. Offense rewards speed, improvisation, and supply. The Americans had more of all three with every passing month. What Joachim Peiper saw at Habimont on December 18, 1944, was not just a single bridge collapsing into a Belgian creek. He was watching, in miniature, the entire engineering war of the Western Front. A young American lieutenant, trained 8 weeks at Fort Belvoir or Fort Leonard Wood, supplied with ample explosives by a logistics chain that stretched back to a factory in the United States. Supported by a doctrine that valued the lieutenant's own initiative, doing in 20 seconds what a German engineering corps with all its tradition and skill could not undo in 5 months. The damned engineers. The phrase has come down to us through the memoirs of the Americans who survived that day, through the post-war interrogations of German officers, and through the work of historians like Janice Holt Giles, who titled her 1970 account of the 291st by exactly that phrase. By the winter of 1944, every senior German officer in the West knew that the Americans were winning the engineering war, and that the engineering war would decide who reached the Rhine first. They were right. The Americans reached the Rhine first. They crossed it first at Remagen, at Oppenheim, at Wessel. They built more bridges, faster, under fire than any army in human history had ever built. They cleared more mines in more weather, against more resistance than any army had ever been asked to clear. They paid for it with men whose names are now on highway signs in upstate New York and on memorials above French beaches. There is a small bronze plaque on the bank of the Linna Creek near the spot where Lieutenant Edelstein turned his plunger on the evening of December 18, 1944. It is in French and English. It records the action, the unit, and the date. It does not record what the German colonel on the other side of the creek said when his road disappeared, but it stands at the high water mark of one war and the foundation stone of another, the damned magnificent engineers. If this investigation gave you something to think about, hit the like button. Subscribe to World War Declassified for new videos every day, the stories they never put in the textbooks. Thank you for watching.